In this example 7, it says the tires of a bicycle have a radius of 13 inches and are turning at a rate of 150 revolutions per minute. How fast is the bike traveling in miles per hour? Please note that they're talking about a conversion of miles per hour. All right, well, first let's talk about our linear velocity. So it says how fast is it traveling in miles per hour? Our linear velocity is our change of distance over time, so distance over time. Well, I don't have my arc length, but I do know my radius, so let's convert our s to r times theta. So I will have my s as r times theta over my time. Now first, I do already have my radius of 13, so I can put that information in. And now let's talk about our angle. It says 150 revolutions per minute. That means it goes around in a circle 150 times every minute. Well, if we went around 150 times, each time it went around, it was 2 pi. So that means it's going to be 300 pi, and that is per minute. Let's start putting our information in. So we will start off, we have our 13 inches, and then our angle is going to be 150 revolutions per minute is 150 times our 2 pi, and that's 300 pi radians, and that's per 1 minute. But now they want to talk about miles per hour. So if we want to do some conversions, let's change our minutes to hours. So I'm going to change this, and I'm going to say there's 60 minutes in 1 hour. And how do I know what goes where? Well, I want my units to cancel out, so I'm going to put those minutes as a diagonal. And then if I need to change from inches all the way to miles, let's first start off with inches to feet. I want my inches below so that my inches units will be able to cancel. And I know that there's 12 inches in 1 foot. Now, I believe I added into your notes the conversion of how many feet to a mile. So I'm going to put the feet here so that my units will eventually cancel for the feet. There are 5,280 feet in 1 mile. So from here, what we're going to do is start canceling our units. I'm going to start with that and see what we end up with. Our minutes cancel, then our feet cancel. Our inches canceled over here, and I'm going to highlight in green what we have left. We have our hours, so miles per hour. Now when we multiply, I'm just multiplying straight in my calculator. I'm going to do 13. I'm going to do 3 times by 300. Now the answer they want is a decimal, so I'm going to use the pi button. When I multiply by pi, I'm going to multiply by 60. Then I'm going to divide by 12 times 5,280. So I'm going to multiply that all out, do it in my calculator. Please do use the pi button, and they do want you to type it out as pi. They don't want you to have an answer and then the pi next to it. They want it as a final answer in decimals. So that's 11.6025 miles per hour. For that one, if you did it originally, I think you would have had, without the pi, I think I had 3.6932 pi, and then when you multiply it, that's how you, by the pi, you will get that 11.6025. Now the next one says, how much faster will the bike be going if the wheels turn at a rate of 250? Well, all of our conversion and all our work is actually going to be the same. So I'm going to cheat a little here. I'm going to copy paste. The only thing that's changing is our revolutions, and that would be impacting right here. So in our angle, instead of what was it? It was 150. Now it's 250. So it's going to go around the circle 250 times every minute. Well, to find out our radians, 250, one circle is 2 pi, and we're going to go around that circle 250 times. So I'm going to replace this with 500 pi, and I'm going to do all the same conversions in my calculator. All my units will cancel. I'll type it all in, and then I end up with, when I type this in, as a full decimal, it's 19.3375, and it's miles per hour. From here, they're asking for how much faster will the bike be going? So we're just going to take these two answers we got and subtract them, and that will give us a difference of 7.735 miles per hour faster. That's quite a bit faster on a bike.